So the enter, this one, auto scaling true, we will set it to 20. Then this one, the same here, to 20 for true. This one as well, so we just set it by default. I think by default they should be auto scalable, because we don't have any disadvantage for auto scaling. Even we don't have traffic, our services just won't scale and that's it. But having auto scaling disabled by default, I don't know what is the reason for it. I prefer to have them to be enabled. So yeah, okay, let's leave it as it is. Let's see what we can do here. Auto scaling. Okay, we've done everything here. Integrations, auto scaling true for 20. Right, so here also true for 20. And as we discussed previously, the sync, they have HPAs, but as far as I remember, they had also volumes that are not read only. Yeah, they have PVC that is not read only. So we won't scale this one. For the storage, again the same. We won't scale the storage even. Okay, we won't scale it with the setup, so I won't do it right now. It doesn't even have PVC. Perfect, so we've just set up here. Let's also go ahead and set up Sentry. So here in values, if we scroll down to the Sentry release, for this one, we okay, we aren't using actually. No, we are not using these. I thought we are. So we can have our values next to the configurable stuff. Never mind. Okay, so if we want to edit in my experience, ingress or write it ingress here, enable true all these. No, we don't need to use ingress here because we have set up it there. Single organization, we might leave it as it is. So this config will be later on provided through the dynamic values service. I don't think we need to use any of these, neither any of these. Okay, I would say single organization true because we're deploying for the organization. So yeah, let's go ahead to the Sentry values in the Sentry chart, right, and see. Okay, so first of all, we have Sentry web auto scaling that won't work. Then the worker will work. So we need to go ahead to the worker. It actually worker. So auto scaling. Let's copy all of these. Auto scaling enable true, min replicas 1, max replicas 20, target CPU utilization 50, let it be. So we've set up scaling for working. Let's go down for ingest consumer. As far as I remember, ingest consumer Sentry ingest, yeah, won't auto scale because of the PVC, the Chrome. the Snuba will autoscale. So let's also, alright, but this is under API. Gotcha. Let me see if we are not making the same mistake for the workers. So we're going to have API, and then autoscaling. I'll copy from here. I'll just move it a bit. Okay, so let's take a look on the worker one more time to make sure that we properly set up it here. So worker, right, we have on the same level. That's dope. Okay, sentry, perfect. Cron, Snuba, API, autoscaling, consuming, blah blah blah. So they offering for the Snuba. Okay, yeah, that's fine. That's fine. Let's see what else can we autoscale. The symbolicator, yeah, it should be, but okay, it's disabled by default. It's even disabled by default. Okay, never mind. I'll still set up the autoscaling feed as true, because if it's disabled, then it's disabled. Then API, so we can just copy from here. Okay, perfect. And let's go ahead on the very top to see. Okay, and we still have rely. We need to set up the rely, which is the top level, I guess, right? Rely, and then after that we had web. So let's set up rely here. And the rely, we just put this autoscaling stuff, but we need to adjust it. Okay, perfect. So we have the autoscaling for the rely as well. I guess that's it. That's how we set up this autoscaling. So let me just go ahead and go back to our backup mechanism. So right now we've set autoscaling, and let's take a look on the backup mechanism here. So we enable the backup for our GKE, and we can create a backup plan. Let's take a look how it looks like. So we're choosing the cluster backup plan name. Let's call it DBs, right? Because we're gonna be backing up databases. Right. So okay, can we just okay, it's only support for some. Okay, let's choose Netherlands because it doesn't. Okay, in config backup scope and encryption. Okay, so we can back up entire cluster. Okay, so they are just, okay, they backing up persistent volume data. Okay, not necessarily we want to, yeah, so this is pretty much simple. So yeah, they will just back up all persistent volumes in the cluster. I think that's what we need, right? So okay, gotcha. We can even scale it, right? I just didn't notice this here. So we can even set up a cron expression to, let's say, make this backup every day, and we can set up the retention, and we can prevent. Okay, yeah, that looks well. Looks really simple and straightforward if you use GKE. I'm not sure yet about how we can do it in other platforms, but doesn't matter. So yeah, I'm not sure about how we restore these backups. So it takes a while for it to create, but let's see. So it will just make a backup for the cluster for, let's say, every day. And we can use a okay, just apply it. Perfect. So we have DBs, but let then edit it because right now, so details, backup plan description, scope, okay, scale and retention. This is what I wanted to edit. So let's every day at 3 p.m. but I want every day at 3 a.m. Alright, so delete backups after, I would say, 10 days, prevent deletion for before 10 days, right? Look, this will permanently prevent any removal, no, save changes. So every day 3 a.m. morning, night, whatever, it will make the backup of the cluster. So just from the curiosity point of view, I want to make this backup right now, and yeah, let's click start backup. So configure your manual backup name, let's say initial backup description. Yeah, let's do it right now. Let's make a backup and see. Pretty simple, pretty straightforward. But what I'm really curious to achieve in the backups is usually the most fragile point in our clusters are databases. So for instance, if we have some integration of our database that stores all of our integrational scripts and their execution events, and for some reason this database was corrupted, either just from operational mistake or I don't know, from some other fraud. We hope that any kind of fraud won't happen, but let's adjust our system to be prepared to that. So how can I quickly restore this one database only? So it's not necessarily that I want to restore all the databases in my cluster for yesterday's data, but only this particular one database to the yesterday's data. So in terms of Kubernetes, it will mean that we're looking to restore only one persistent volume. So what we should do, we need to go ahead and see what is the name of this persistent volume of the database, and then go ahead and restore it with the data from some previous day, right? So this is something I'm trying to test right now to know that okay, I'm safe with Kubernetes. Whenever I'm doing there, it will be safe and I won't lose any kind of data, because data is the most valuable point for the Kubernetes. Because even if your service configuration will crash, something like that, you go ahead to your Git and pull your Kubernetes scripts, your Helm scripts, and redeploy your cluster again. But what you want really do, you want to this redeployment to store the data produced by the cluster. So yeah, this is what we're trying to achieve right now with that backup mechanism. And after you have the backup, after you have the scalability, we have pretty good reliability of our cluster. And so what I want to do, I want to set up some load tests to see how because regarding the integration, I'm pretty sure the integration service, autoscale is a simple service, nothing complex. It will just handle the traffic autoscale, there's no problem about it. But what about Sentry and OpenReply? Some of their services that support autoscalability by the config don't have the scalability because we didn't enable because of the persistent volumes, right? And my just guess is, what if those services are some business logic crucial and the lack of autoscalability there cause some problems during the real load? So that's why I want to somehow emulate the real load for the application and see how it behaves. I guess we will create a separate live stream for this later on. So, and to give you a brief guess how we're gonna be doing it, what we're gonna do, we will integrate our Sentry and OpenReply into our web application, And then we'll go ahead and set up some UI workflow tests for this application. So there is a tool, I forgot his name, that allows us to just, so we're making some clicks, we're making some stuff on the web app, and it will just replay what we did. So we will record some kind of a few user behaviors, a few usual user behaviors. So for the e-commerce store, it's gonna be like open the website, take a look on the products, a few more products, see sizes, see whatever, add to cart, reads the size chart, reads the support information or some shipping info, then make a checkout, right? Then pay, and then yeah, that's it. So we will set up the scenarios like these for our web app, and then with connected OpenReply and Sentry, we will run those recorded scenarios in parallel with, let's say, 1,000 or like a few hundred replicas of this instance. This is how we create load tests, and thus we will be able to see how our self-hosted services are behave on a larger scale even before going live. And this is something that not just I figured out myself, but a lot of, if you talk about some big companies like Google that have really well-established site reliability engineering practices, so they have a golden rule that before going live with some new advanced changes, they are making, they are emulating the real traffic on their stage environments to see how the system behaves under the load before moving forward. And we're gonna do the same. We're gonna have kind of our scientific lab here where we're doing all of this stuff. That's pretty interesting, right? All right, so it still makes a backup. I know that there is a lot of stuff to do with that thing. So yeah, it might take a while. I don't know how much time it will take. In the meanwhile, what I can do, I can apply my changes with the autoscalability and see how everything will work. Let's just make sure that our cluster is responsive. Yeah, it's response, so we can go ahead and just with one command apply our complex multi-services, multi-nodes, multi-load balancers deployment configuration of the Kubernetes to Google Kubernetes engine on Google Cloud Platform. And let's hope that everything will work well, because we just set up autoscalability. So everything seemed to be all right. I forgot to add the scalability to Sentry. Okay, let's make this deployment for just OpenReply to scalability and see if the service is working without any judgments further. And here I just forgot to add this values file to my Helm file. So in the values here we have our YAML defined values. We also go ahead and add the config of the Sentry /values YAML, right? So we're just adding the path of this file here, and also adding some kind of custom config. This is the beauty of the Helm file, help us to do such things. Let's see. So it seems to be working well. Let's also go ahead to the Helm docs, Helm file docs, just to make sure that I've set up these file input properly. What a yummy food we see here, right? Okay, perfect. So let's take a look to the values like these. It's better for me to search. Yes, we can simply specify the path to the file, and then we can, so we did it right. All right, so our deployment is still going on next to our backup, which is processing now. it works well. It works well, so let's leave it. I guess this backup will take, it might take up to an hour, because we will have a lot of persistent volumes and really complex infrastructure here, so we can just go to the storage and see how many volumes we have. Alright, so we have 28 volumes, right? So this is a lot. And yeah, that's why this backup might take, I mean, those values mostly empty, but still, you know, it takes some time. So I guess we won't cover the backup recovery in this live coding session, because even if you want, we don't have any, as our cluster is fresh, I guess we don't have any old data. So I guess for the next few days I'll be doing some integration, so there will be some data in our databases, and we will make a real life example of it. We will try to restore the data for one of the databases for like a day ago, right? So let's just make sure that it works. So oh yeah, it's still, deployment is still in progress. Still takes some time, maybe because it's slow a bit, because also the backup, it takes some resources from the cluster. Usually you should choose the time frame during the day where there is the least amount of traffic. Okay, perfect. So we applied it. Let's just take a look. kubectl get post in the our namespace, because we just did, everything seems to be running smooth. Let's also check the address here just to make sure that app are responsible. So yeah, nothing broken. That's well. So let's run this helm file, apply one more time to apply the things regarding the sandwich that we just made. Okay, so they're running. Let's take a look on backup. It's still running. Perfect. So I think we've done those things that we wanted to do pretty much easily. At the beauty of Kubernetes. A lot of people, if you're talking about Kubernetes, they just watching on you with the big eyes, like you need a whole bunch of understanding to set it up. But honestly, if you're talking about some kind of reliable applications, it's easier to do them with Kubernetes than with any kind of other, because like, what do you need to do to deploy the app to the cloud, right? You have the web app with backend with database, the simple scenario. You'll go ahead to AWS, and the easiest way for everyone probably is to launch the VM and run the app here, right, on the one VM, just to have it running, and that's it. But this approach is really unsustainable and unreliable, because you don't know whether it's running or not, what errors it's producing, you're not monitoring anything, and then you get a bit of a traffic, and let's say your database try to consume all the CPU, your application become unresponsible. So yeah, this is the worst solution, and this is like how most people are starting. It's probably okay to get started with, but even if you started, it's really, sometimes you just want to have a reliable hosted version of your application to show, even just the prototype to show your investors, potential customers, whatever. And then in some responsible moment it just stops working, or you just need to spend some time, okay, why is this server crashed again? Because you have there, and you're just thinking, okay, I maybe need some more advanced configuration, but I don't have a big clue about cloud computing, and it becoming a mess. Yeah, so some smarter way, there are AWS creating a whole bunch of services for these, like Elastic Beanstalk, right? Google Cloud has like Cloud Run, App Engine, so you can run your application under those services. You can spin up the managed database. So the managed database will cost you more. Furthermore, you need to pay for the two instances, one instance of your app, one of the database. It will bring you a bit more of monitoring, so you will have more understanding of the system, but still, if your app crashed, it will crash, and you can even more notice it, but at least you'll be able to see the logs why it crashed, right? So this is the better, but still not as reliable, because if you really want to go as reliable as possible for the real, just make sure that, I'm not talking about really some huge cluster scalability or some huge traffic handling, but just a simple deployment that will make you sure that it won't be running, and whenever you're showing your prototype without traffic to your customers or to investors, it won't crash. If you want to set up purely on some AWS or GCP, believe me, it's more complex than on Kubernetes if you're starting from scratch, right? Because it's not enough to set up App Engine or Beanstalk itself. You also need to figure out some monitoring, figure out some logging, figure out some auto-scaling, figure out all these. And if we're talking about all these complexities that are arising there, it's much easier to set up all these in Kubernetes than on the AWS. I've been setting up AWS CloudWatch, GCP monitoring for a whole bunch of companies, and I know that in Kubernetes you just spin up open source application. It's much easier to manage it, control it like this. Okay, so no more talking. So we have the deployment successful. Let's see the pods in certain namespace to make sure that they are not crashing. So we have a bit of latency here to get a response from cluster, because yeah, everything is running smoothly. And finally, I'll go and to the domain here. Okay, that's dope. It works. And yeah, getting back to this topic, that if you really want to set up the sustainable, reliable, auto-scalable, faultless deployment, no matter if it's just for prototype or for really handling big customer spikes, the reliability important in both cases, because as I mentioned, the first impression of your application that crashes for an investor might ruin your business. So it's much easier to do with Kubernetes than with any kind of platforms like this. But in some cases there is a probability that you might want to use the AWS because of, I don't know, political reasons, or you have a free creditor. Then you can either use the hosted Kubernetes, or you can go ahead with some other services, but you will need some DevOps who have a clue about how to manage them, how to properly set up them. Yeah, so this is the beauty of Kubernetes, because it's pretty much straightforward. You do everything in the simple YAML that well documented. You can troubleshoot it on Stack Overflow, whatever you want. And yeah, you can understand the deployments of different open source projects by you looking at their deployment Kubernetes charts. Alright guys, so thanks everyone for joining me today. We managed to set up the auto-scaling and backup mechanism for our Kubernetes cluster. It was not as complicated, but it was just a setup, and we see that nothing suspicious happened, so looks like everything worked, right? We can't make sure on the 100%, but in one of the following streams, what we're gonna be doing, we will be making the restore of the backup. That's the one thing. And the second thing is we will be making load testing to make sure the auto scalability is working smoothly and it's able to handle the larger traffic spikes. So thanks everyone for watching this stream. If you're watching recording or if you're watching live stream, no matter if you have any questions or any suggestion about it, feel free to add the comment or ask them right now in the chat box here. In any case, I appreciate your time, guys, watching these. And if you like these, if you like those stream sessions, just hit the like button so I know that some people engaging with that. I'll be happy to create more live streams for you, so please subscribe to my channel so you'll be notified about any new scales, any new stream that will be released soon. So thanks everyone, I hope you have a great day, and I'm looking forward to seeing you in my next stream, and I guess it's going to be tomorrow. I'll keep you updated in my LinkedIn and on the YouTube as well. Thanks, bye.